The following graph of potential energy is used for questions 18 through 20. So in this given diagram, we have potential energy in the vertical axis and the position in the horizontal axis. So knowing what's going on in our diagram, we'll answer number 18. Which of the following represents the force corresponding to the given potential? Okay, notice it said force and given potential. The given potential is pretty much the potential energy that you see on the vertical axis in the given diagram, and then the force is what you see in the in our given choices on the vertical axis. So in other words, the question is asking the relationship between the force and the potential energy here. So if I write the relationship between the kinetic energy, or actually the work done, and the potential energy, I can write it as the total energy is conserved. So kinetic energy plus potential energy equals 0. In other words, one form just converts to another, and we also know that work done is pretty much delta K, and that can also be represented as integral of f of x times dx. So we are adding the infinitesimal distance of each force, and when you sum it up, we get the kinetic energy. So if I rewrite this in terms of delta U, I get delta K equals negative delta U, and I'm gonna use the integral fx dx instead of our delta K. We have f of x dx, and I'm also gonna multiply negative on both sides so that I have just delta U this shows change in delta, but we're gonna set the initial potential energy to be 0. So we're gonna have u to the x minus u to the 0. But for simplicity, we're gonna just cancel that out to be 0. So u of x, u of 0, we're gonna set that equal to 0. Okay, the x stands for the position, and then that also makes the integral calculation to be easier as well. So we have negative 0 to x, and then f of x dx. Now we want to get rid of that integral, and to do that we use a fundamental theorem of calculus. So we're gonna put the dx on both sides. So what we're gonna have is put the t over dx times ux equal negative d dx So what happened is, using the calculus, this side just remains, the left side only remains the force, x, and then on the right side we have, okay, technical minus in front, and then we have the d over dx, u to dx. Therefore, we can just write it as f of x equals negative t over dx, u to the x. So we have the derivative. So remember, every time that derivative is shown, we are finding the slope of potential. So slope of potential energy gives us the force here, but it has some negatives in front, so negative slope of potential energy. keep writing their PE. Alright, in this case we have U, so I'm going to use U as a potential energy. So you have to just find the negative slope of each of our given line here in the given diagram, and then the corresponding graph will be our force versus position graph. So let's take a look. So now that we know the relationship between these, we have slope of 0, slope of -1, and slope of +1, and slope of 0. So looking at our choice from -15 to 5, no, -15 to 10, so let's divide it. So -15 to 10, we are observing the 0 force. Everybody has 0 force there. However, from -10 to 0, negative 10 to 0, okay, we have -1 here, but this has to be now converted to +1, and that has to be converted to -1. Again, I'm demonstrating that we have negative in front of it, so it's negative slope of U, so we have +1. So I see -1 here, so A is out. I see -2 here, B is out. I see +1 for E, okay, that's good. And that's like -0.5, so C is out. And that's like a 0.5, oh, we don't even have to do anything. So you just know the answer is E. Okay, but I will make sure that this is correct answer. So we have 1, and then, okay, you want to see that the slope to be that, okay, we have a cusp here. In calculus, whenever you have cusp, we don't really get to find the slope because this is not a continuously smooth curve. So that's why at 0, the left side limit and the right side limit are not equal, so we cannot determine 0. That's why we have a straight line here. But looking at the interval between 0 through 10, we are able to find the slope. So we are supposed to get -1, and looking at this, it is -1. So this is good. And finally, from 10 to 15 meter, we have 0, and we have -0 is 0, so this is perfect. So E is our answer.